Hashtag GPU announcements and performance gains, TechNavigator Pro tutorial script. You're probably upgrading your GPU without knowing what the actual performance gains mean for your workflow. Let me break down exactly what's changed in the GPU market and why it matters to you right now. If you're a gamer, a creator, or someone running AI tools, you need to understand the real-world impact of recent GPU announcements. Because here's the thing, the marketing numbers don't tell the whole story. Let me start with the problem. When manufacturers announce new GPUs, they throw around percentages. 30% faster. 50% more memory bandwidth. But what does that actually mean when you're rendering video, playing games, or training models? Most people have no idea. Here's what's actually happening in the GPU landscape right now. We're in a critical moment where artificial intelligence acceleration has become just as important as raw gaming performance. That's changed everything about how GPU companies design these chips. According to the latest technical documentation from major GPU manufacturers, we're seeing a fundamental shift toward unified memory architectures and tensor core specialization. This means modern GPUs aren't just good at one thing anymore, they're optimized for multiple workloads simultaneously. Let me walk you through exactly how to evaluate these announcements for yourself. First, understand memory bandwidth. This is the speed at which data moves to and from your GPU's memory. When you see announcements highlighting bandwidth increases, say, from 576 GB per second to 960 GB per second, that directly impacts how fast your GPU can process large datasets. Per recent specifications from manufacturer technical briefs, this translates to real performance gains in video editing, 3D rendering, and machine learning tasks. For gaming specifically, you'll see smoother frame rates at higher resolutions because textures and geometry data load faster to the GPU cores. Second, focus on core count and clock speeds. But here's where most people get confused. More cores sounds better, but it only matters if you're doing parallel workloads. A GPU with 16,000 cores means nothing if your software only uses 4,000. Check the documentation for your specific applications. Look at the spec sheet on the manufacturer's official product page, you'll see technical specifications listed. Click into the Performance Specifications section, and you'll find exactly which operations benefit from higher core counts. Third, evaluate memory type and amount. This is critical and often overlooked. Newer announcements tout GDDR7 memory or HBM3E memory. The difference? Speed. GDDR7 can reach memory speeds around 36 gigabits per second, while HBM3E pushes 1.2 terabytes per second bandwidth. According to the latest architecture documentation, this matters enormously if you're working with large datasets. If you're rendering a 4K video in DaVinci Resolve, or training language models, or processing massive datasets in Python, these memory improvements directly reduce your render times and processing speed. Now here's the real performance metric you should care about: power efficiency. Recent GPU announcements emphasize performance per watt. This isn't marketing fluff, it's physics. A GPU that delivers the same performance while consuming 50 watts less electricity means lower cooling costs, quieter systems, and less strain on your power supply. Check the Thermal Design Power, or TDP, on the official product specifications page. Look for the power consumption metric. Lower TDP for equivalent performance is genuinely a win. Fourth, examine AI and tensor performance. If you're using any modern software, Adobe Creative Suite, DaVinci Resolve, or machine learning frameworks like PyTorch or TensorFlow, your GPU is probably running AI-accelerated features. According to recent announcements from major manufacturers, tensor performance improvements of 200 to 300% directly impact upscaling features, neural filters, and real-time effects. In DaVinci Resolve, click on the Fusion tab, and you'll see the neural engine running. Better tensor performance means faster previews and real-time processing. Fifth, look at real-world benchmarks from independent sources. Not the manufacturer's own numbers, those are accurate but cherry-picked. Visit reputable tech publications and search for benchmark comparisons. Look specifically for benchmarks that match your use case. Gaming benchmark? Check Tom's Hardware or Gamers Nexus benchmarks. Video editing? Search for DaVinci Resolve or Premiere Pro performance comparisons. AI workloads? Find CUDA or ROCm benchmarks that align with your software. If you're finding this valuable, hit that subscribe button. We post tech tutorials daily, and this stuff compounds. Next week we're breaking down how to actually match GPU specs to your specific workflow. It's way more nuanced than the spec sheet. 6th, consider architecture generation differences. A newer architecture running at the same clock speed as an older generation will often outperform it. This is because newer architectures have improved instruction sets and better data flow. When you're comparing GPUs, don't just compare the numbers, compare the generation. A 2024 generation mid-range GPU might outperform a 2022 generation high-end GPU in many tasks. 7th, understand software support and driver stability. This is where many people get burned. A GPU with incredible raw performance means nothing if your software doesn't support it well. Check the official driver release notes, these are available on manufacturer support pages. Search for your specific GPU model and the software you use. You'll find driver version requirements and known optimizations. 8th, evaluate value relative to your specific needs. This is the real secret that nobody talks about. A $300 GPU might give you 85% of the performance of a $1,200 GPU for your specific workflow. How do you know? Benchmarks that match your actual use case. If you're primarily doing light video editing and some gaming, you don't need the flagship. But if you're rendering complex 3D scenes or training models, you absolutely do. Here are the pro tips that separate people who get real value from their GPU purchases from those who waste money. First, check the release notes and technical documentation before upgrading. Manufacturers publish detailed architectural guides and optimization documentation. These aren't exciting to read, but they tell you exactly what improved and why. The official product documentation pages have PDFs you can download, they're free and incredibly detailed. Second, monitor real-world performance in your actual software. Don't rely on benchmarks alone. Run a test project. Render a complex timeline in your video editor. Run an AI upscale filter. Time it. Do this on both your current GPU and the new one you're considering. That's your actual performance gain, and it's the only number that matters. Third, consider the total cost of ownership. A more efficient GPU consumes less power, generates less heat, and requires less cooling. Over 3 to 5 years, this compounds into real savings. Fourth, track driver updates. After purchase, GPU drivers get better. Manufacturer optimization updates can improve performance by 5 to 15% after the initial launch. Subscribe to the manufacturer's driver notifications for your specific GPU, they're available on the official support pages. Here's what the GPU market looks like right now if you zoom out. We're in a unique moment where gaming-focused improvements and AI-focused improvements are converging. The same architectural innovations that made GPUs better at gaming, larger caches, improved memory controllers, specialized cores, also make them better at AI acceleration. This means the next GPU you buy will probably be future-proof longer than previous generations. Remember, we help you navigate your tech journey with confidence. That means making informed decisions based on actual specifications and real-world performance, not marketing hype. Understanding these GPU announcements and performance metrics puts you in complete control of your upgrade decisions. If you want to go deeper into this, hit that subscribe button. Next week we're comparing specific GPU models head-to-head for different workflows: gaming, video editing, AI, and 3D rendering. You'll see exactly which GPU wins for your specific needs. Subscribe now, and let's navigate your tech journey together with confidence.